Hey guys, Crafty Dan here. Playing around with something new, and it's just, I hate to say it, this little thing is just proof that I can be bought. Had a friend of mine chatting about a project that I was working on, and it's one of many things that I've been working on. And this one had been stewing in my head for quite a while, but it's so far down on the schedule, I don't think I'll ever get to it. And he says, basically, if you do it, I will, and he bribes me. Positive side is this project was dirt simple, real quick and easy to put together. And it does take a little bit of setup to understand what exactly these little thin strips are. So that this video will be a little bit more extended, and there's going to be a lot of things in it. Either way, just got these back from OSH Park. They're cute. They're wonderful. OSH Park is it's a good PCB fab company. You send them Gerbers with the PCBs you want set up and built, and they print them out. It takes about 2 weeks, so their production cycles 2 to 3 weeks. Their production cycle's kind of slow, but really cheap. Think they sell it in batches of 3, and 3 of these little guys here costs me a total of 50 cents a piece. So all 12 you see here is like $2 worth of cost shipped. So kind of cool. Anyways, they come together sort of snap together. Sometimes they're broken, and usually that's probably done in shipping or anything. But either way, they're perfed together with little bitty tiny drill points just to hold them in the die. So they're real easy to separate out. And what these are, this little PCB is designed to make your lights be super fancy, and particularly your RGB lights. So my main principle in anything that I do with RGB lights, any lights really, is because they're a little finicky and a little flaky, and they're difficult to water and solder up and everything, and anything can go wrong at any time, is you always set up some way to test, and you test it throughout. From start to finish, every chance you get, you test. So what I'm going to do is I'm going to go start to finish on a little bitty prototype test for this guy. Just the other day, I picked up 5 of these little packs. I think 20 bucks, so they ended up being about $4 a piece. I keep these in stock for whatever I need, and it's a little bitty RGB LED controller. It's RF based, so you can build it and embed it in your wing. You don't have to worry about sticking anything out. There are IR versions of this, and they have a little dongle that pops out, and they're absolutely horrible. Mostly because they're oversized, and you've got this little bit of extra that you have to have exposed to something outside so the controller can get to it, whereas this guy can be controlled from anywhere. But lots of extra plastic doohickeys and whatnots. They're kind of nice whenever you're trying to hook up something in your house or wire up a tent with super duper lights. But if you're trying to put this in an airplane, lots of extra wasted weight. So we're going to do a few things to it real quick and make this a little bit easier to work with. First things first, let me get a sharp implement. First thing I'm going to do is I'm going to show you what's inside these guys. And there's not really a whole lot to them. Usually what I will do for cutting, I will start at one of the connectors and work my way across the connector, and then I'll run across the edge of the board itself as I cut the PCB, or excuse me, the heat shrink, because I'm less likely to cut a trace on the board or damage one of the components, particularly if I don't have any idea what's underneath that cover. So I'm just going to very carefully cut, trying not to slip off because that can get painful, and more importantly, it can get kind of damaging. Okay, and I've actually cut open probably about a half dozen of these already, and you end up with a cute little PCB like this. You see on one end you've got this little snaky wire there. That's the actual RF antenna with a crystal at the end of it. Driver circuit, a controller, power, which is kind of nice. And sometimes I've seen these things labeled as plus and minus, sometimes not, but it's best to keep an idea of which one's plus and which one's minus, because you don't want to wire these things up backwards. And then you end up with these 4 control points here. Those are the signal outputs. Now, if you have the cover on it, the cover itself has a little bitty red arrow. The arrow can change by color, it's not that big of a deal, but the little arrow usually points towards the ground the power connector. RGB LEDs are common power with the colors themselves grounded. You ground the color and that lights up those LEDs, completes the circuit. And there's not really any marking on this side of the board, but you flip it over and you look at the layout of the circuit itself, you can see this, which one of these 4, which one's different? Yeah, this one's different. It's got this big long line over here, and if you look on the other side, the flip side of that big long line, there's the positive, that's the power line, that's the power line, here's the power side. So of all of these, the common power connects to the common input power. And then the grounds themselves come in here, and they get modulated by these little transistors in here, and that's what the smart circuitry in here is for, and return back to ground there. Simple circuit. So, flipping on my soldering iron, get it nice and warmed up. So what we're going to do, I'm going to go ahead and I'm going to cheat today because I'm just testing, and I've got an actual circuit to hook this thing up to power it. But because I believe in testing all the way, at every opportunity, I'm going to go ahead and plug this thing in here. Now this circuit is live, but not very interesting, which is why I need these. Okay, this is my set of, it's a spare set of LED strips. Those are RGBs. I got them real cheap, and I've been working my way through the strip just a little bit at a time. And so what I'm going to do is I'm going to hook it up, and on the strip itself, it's hard to see, on the strip itself there is an arrow. The arrow goes towards power. As we determined before, the power comes on the red side, so we're going to hook up the red arrow to the power. Hey, looky there, lots of flashy lights. Just because I can, I pull out the remote, pull out the little circuit thingy, or little battery thingy, and I can hit the power button and it turns on and off. I can change the mode, make this thing really, really annoying, or I can go to the flashies. Now this is all nice. This is a great little controller. You can take this, I'll take it usually at this point, and I'll resolder these points here to a battery connector, then I can hook it up to power, or I can hook this into whatever. But I supply the power here. I'll rewire this into the connectors for the aircraft itself where the lights are, and then I'll heat shrink it. Real simple. Way lighter than the original. This big nasty plug mess is just way too much weight. So I can play all sorts of games with that, but you'll only ever get those colors out of it. It makes for a nice uniform monotone wing or aircraft. If you want multiple colors out of the same aircraft, you've got to basically separate out your strips and have extra controllers and whatnot. And honestly, I think that's bogus. It's a waste of time, particularly since I usually want my lights to be in particular patterns that are somewhat fixed. I like changing colors, but I like my colors changing in very particular ways. That is what this guy will do for me. I've been doing it by hand. I don't have to do it by hand any longer. So, first things first, let's go ahead and unplug. My soldering iron is telling me that it is nice and hot, and we have verified that this guy works. So, first things first, that connector has got to go. So I take my soldering iron, and then I go get to hunt for solder. those projects where you know you have everything with you until you try to do something. Yeah, that's every project for me. Okay, so get our soldering iron. We go ahead and clean the solder. Melt a little on there. And I'm using a pair of clippers. It doesn't really matter. I just need something to put a little bit of pressure on it as I reflow the solder. And it's gentle pressure. I just want to get these things to lift in the melted solder. That's it. I don't want to pull up the pads. So I'm not really giving it enough to really damage the pads. And then I'll reflow the solder just a little bit more. And what I'm doing is I'm putting just a little dab of solder from here onto the iron itself, just to put a little bit more flux into the joint. That causes the solder to want to flow towards heat, and that guy is the hot spot. So now I've got this. Next trick is to wire it to something useful. And for that, oh, I've got such a scrappy, messy desk. I'm going to use this. I love ribbon cable for this kind of a job. It's perfect. Usually comes in strips of like 40 wires, 40 conductors. And generally I only need 4 at a time. So I'll just go ahead and I have stripped a section of 4 from them, and you just effectively grab it and you peel it away. You peel off the 4 that you need. Clip. Now you can take and you can individually strip each one of these wires. It's a bit of a pain. I've done it. I've done it many, many times. I did an entire wing with about 26 panels in it with one of these little LED strips between each one of them using this wire. And that means you strip 4 times for each one. Oh, twice per each side. It got a little painful. Either way, I found this guy works great. Just sort of stick it in there. Line everything up. Strips 4 perfectly every time. Can't really guarantee that they will all work that well, but they tend to. And as you can see, as those people who've been observant, one too many. Beauty of it is, as long as I don't put too few, I'm good. So what I'm going to do is I'm going to peel back just a little bit of each one of these so that I can get the individual wires. I'm just going to prep them a little bit because I've done it before without prepping and it's a pain in the butt. And all I have to do is take each wire and twist it. That's it. I'll tin it after these, but if you don't twist as you tin, when you heat the solder, the wire will have nothing to hold on to. Each individual strand in the wire won't have anything to hold on to. It won't be able to hold on to its nearest neighbor anymore because the solder is not holding it in place, which means you start getting frayed ends to these things and it becomes an unholy mess. If you roll it first while the wire is still not soldered, it all stays together and stays as one uniform solid piece of metal, and you can tin it and it will work fine. So next stage is the tinning. And I cut them along because ribbon cable generally you have more than enough to waste, and you just add a little bit of solder to it, make sure everything's nice and clean, and you tap it on. And ideally it would be nice if you go ahead and put heat on one part of the wire and then use the wire to conduct the heat over to the solder itself. Adding a little bit of solder to the iron to start just is nice to get a little bit of flux on there and a little bit of heat to start the process, but then you want to use the wire itself to melt the solder in. That way you know the wire has gotten hot enough to melt the solder, the wire has gotten hot enough to bond to the solder. The other thing is, between each one of these things, because I want a good clean joint, I will clean little dinking business in the background. That I'm going to clean the iron itself. So I've got a nice iron to start with nice clean solder with just a little bit of flux left on it. And there we go. Easy peasy, lemon squeezy. And of course these are a bit long, so I'm going to come in here and just go clip, 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 clip. Well, actually, I like to clip these all at the same time so they're all roughly the same length. And okay, yeah, they look really, really small, but you lay them up against their pads, they're really not that big. So it's actually just about right. And frankly, I've done enough of these. I got an idea of how long they need to be. So I will go ahead and put a little bit of solder on here to make sure that there's a little flux in the joint. And just tap. All I'm doing is melting the puddle of solder, letting the wire sink into the solder. There is enough heat, or there is enough solder there and little enough heat needed that it just sort of sinks in and melts. Two things to be aware of is that you don't want to go too many of these without cleaning your iron. You can go 2 or 3, but I wouldn't go more than that. And then, you know, just tap it, sink it in. If you start seeing it pull up like that with the little bits in the end, you'll also notice it's starting to get a little bit of less shiny than the others. That's actually a bit on the cold side. Remember, well, actually no, that's not the power joint. That's one of the grounds. It's just being fussy. Generally, that tells me one of two things: either I'm not gotten enough heat into the joint itself, or the metal pad underneath is sucking way too much heat away from it, or there's not enough flux in the joint, and so the metal is having trouble actually flowing like liquid. So you can either cheat by using the solder using the flux in the solder, or a can of solder paste. I will pull out the solder paste whenever it gets really, really bad, but usually that wasn't anywhere near as bad. Okay, so this end is done. It's time to do that end. And we repeat. Now, if we are doing this in an aircraft, in a real airplane, I would have done a little bit of planning ahead of time. This would also be heat shrinked. I would have taken this part and found where I wanted to hide it in the aircraft itself. I've hidden this various places in the wing. In the box spars on flight test planes, it's easy to hide in the box spar. I've hidden it all the way in the nose of some wings. In fuselages, I mounted it into the wings of something that the wing was removable. So all I had to do was apply power to it, and all of a sudden the wing glowed with multicolors. It's kind of cool. I've also put this inside the fuselage, or inside the fuselage of planes itself with removable wings, and then put a 4-pin connector on it so that the wing itself and the fuselage would match in pattern, or would stay in sync with pattern, because they're all being driven off the same controller. It's up to you how you want to run it, but this is about the time you need to start, just before you solder this piece on, you start thinking about where you want to put it, how long is the run, because if the space between this and the start of your LEDs is a really long distance, you want that to be a long piece of wire. If the space between here and the battery is long, you want this to be a long wire. You sort of start sizing out where your wires want to be as you solder them on, so you don't have to solder multiple times. The other thing is, this is about the point in time, if you're about to do on a long strip and you've already got a battery connector on here, you really want to slip the heat shrink over top of this and shrink it down. Since this part is temporary, I am throwing it away very shortly. I don't have to do that yet. But do keep that in mind, because desoldering just to resolder things back on so you can put the heat shrink on, pain in the butt. And it won't be the last time I have to do it. It won't be the last time you will. Just try and avoid it where you can. So again, with the twisting, I pull as many of them away from the one to be twisted. Twist it, pull it up, And when I'm doing lots of these, like when I did the entire wing, it was a nice, beautiful balsa wing with, I think it was 13 panels on either side, so that's a 26 or 13 rib spacings, shear webbings, whatever. That I put one of these lights between one of the LED light strips between each one of the ribs. Really a lot of work. Came out absolutely gorgeous. And I still fly that plane today. It's a nice little pretty night flying ridge runt. I'm going to have to do some more things to it just to snazz it up a little bit more. But the wing itself is just spectacular. But you get a rhythm when you start doing a lot of these. Positive side is if you're just doing this for just to use these strips that I'm about to show off, that may be the last 4-pin solder joint you have to solder. Is the main connector onto the first strip, and everything else, it's easy peasy because these guys make it easier. So, 4 strip like here. Now, onto the strip, and this is a bit beat up strip. It's been to several different festivals and fairs and whatnot, and events, and it's been slowly stripped off and slowly losing more and more of the individual elements as it gets used up for projects. But that's just sort of why it's beat up a little bit. So the first things first, tin all your connectors, little heat on the iron, little heat on the pad, little solder on the iron, little heat on the pad, little heat between the two of them, and the solder will flow. If you're wondering, I usually have my irons set fairly low, especially for a lot of this electronics here. Mostly because it doesn't take that much heat. This one is set to 600 Fahrenheit right now. If there was a lot more heat sink involved in this, and I have had some of the bigger strips do that, then I might bump it up to 650, maybe up to 700. ESCs and such, generally the ground planes on them are really, really big, and so they'll suck up a lot of heat, and then I'll start jumping it up to 700. When I'm doing soldering of large wires, then I'll go up to really high temperatures, like 750 or so. I really usually don't go that high. I use a thermally controlled iron. So the iron itself does its best to keep at the temperature, and it doesn't overheat these components because of it. So, before we go, and before we solder this thing on, we need to make sure that we have the positive side connect to the positive and the 3 grounds connected to the 3 grounds. Now, first things first, we know that that's the positive, it's connected to here, so that's the positive. Flip it over, this is the positive, the one on the right side. So hey, look, they're lined up. That's perfect. If they were flipped over, I wouldn't have to flip them over. It's not a big deal. Now, red, green, and blue. Which one's red, which one's green, which one's blue of this thing? The whole core principle of this thing is the controller doesn't know, the controller doesn't care. Some of these switches and such will actually have manual colors that you can press the button, and at that point, you know, the color might actually matter. It doesn't really in something like this, because it's just going to, it just treats them as 3 different color and will randomly cycle through them, or sequentially cycle through them. If you swap green for red or red for blue, it doesn't know, it doesn't care. So on the board itself, it's not really labeled, because it doesn't have to be. On the plastic itself, it sort of says RGB LED, but it doesn't say which one's which because it just doesn't matter. Okay, so we've got this, it's already trimmed up, and so we're going to repeat this one more time. Now, there should be a decent amount of solder, a decent amount of flux inside each of these joints because they've been freshly tinned. And I'm going to cheat a little bit and make good use of that. But before I do, let me go ahead and clean the tip. And all you have to do to clean the tip is put a little bit of solder on it and poke it into the cleaner. That is not steel wool. Do not use steel wool. That's a brass wool of some sort. And it does a decent job of just sort of stripping it off without burning. But the little bit of extra tin, or a little bit of extra flux in the solder, will sort of float all of the gunk and corrosion up to the top, and then it can be brushed off real easy. So then, And the little bit of smoke that you see as you come up is actually good. That's the flux starting to burn off. And if you see it, that means you actually have some flux in the joint as you're soldering it. That is a good sign. If you start putting it on there and you don't see any heat, you don't see any smoke, things don't come back to silver, seriously, reflow the joint, clean the iron, take a little bit of fresh solder, put a little fresh solder in there. If that's still not enough, again, go back to the solder paste. It makes a huge difference. This stuff is great. It's sometimes easy to overuse, and there's usually enough in the solder itself, but it does make life a little easier when it starts getting hard. Okay, so we got this thing soldered up. I'm going to disconnect this because it could possibly short some things out. Okay, now and off camera, because I don't have really good control of the camera, we're going to plug it in. And turn you on. And we learn why we test. Now, folks, we get to do a fun thing called troubleshooting. What did Dan do wrong? Oh, Dan did wrong. Dan did big wrong. After talking to you about why not to do things in the right, why to make sure that plus goes to plus and minus goes to minus, I screwed up. This is the plus side. You follow it straight cable. Yeah, I'm trying to power blue. Now, the beauty of this is these are all diodes. So they're going to be, when they're reverse biased, they don't allow any current to go through, so I haven't burned anything up. I just don't have anything that works. So we get to demonstrate one more thing of how do you fix things, Dan? And we do basically what we did before. So I'm going to put a little bit of pressure on the wire, twisting it just a little bit, so when I put a little heat on it, the solder starts to melt. It just peels right away. Okay, now we're going to try this once again. Plus side goes to plus. Dan, let's try to do it right this time. Okay. And I do need to clean the solder. I haven't run out of solder, out of flux in these pads, but it's getting really low. So I need to make sure that my iron is nice and clear. Nice and clean. Okay. So test 2. And also evidence and proof. Why we test every joint. Now here's the fun part, guys. We are just getting started. The whole point of this video is to demonstrate this guy. Until I got this far, I can't really demonstrate this guy. So, we're going to unplug it. And, well, when you look along the strip, the next break, you'll notice that these have natural breaks in them. Well, a strip in an area here where 4 leads are connected together. They're actually continuations of the same wires with an exposed end to it. The exposed end can be used as pads to tap off of. The idea is the pads themselves are wide enough that you can actually cut them in half right there, and you've got a left and right side that you can solder to. So that you could make, this is an individual unit of these 3 LEDs, could be an individual array of LEDs, and then you wire up this guy as in a separate spot, and this guy in a separate spot. The trick that we're going for, and you'll notice every once in a while, and it's actually fairly regular on the strip, they make the strips themselves a very fixed length and then sell them at 5-meter lengths, but they're actually much shorter. So we'll solder them together into individual strips to make the much longer 5-meter strip. So, a couple of options here. I can come in and I can cut the backing here. And you know what? I might just do it that way. I can cut the backing here. And my goal isn't so much to cut the strip, it's to cut the strip and the adhesive behind it. Because they'll lay these and they'll put these together in one long strip, and then they apply the adhesive to the back. So the